Okay, welcome to lesson 1 on types of reactions, and we're going to be focused on three types of reactions: on precipitation equations, on neutralization equations, and we're going to dabble a little bit in some redox. One of the key things or skills that you need to be able to demonstrate in types of reactions, in particular with the precipitation reactions and the neutralization reactions, is your ability to take an ionic compound and translate it into ions. So we're going to practice that here as lesson 1 a little bit before moving on to actually messing around with the equations. So there's a couple things I want to remind you of. In order to do this, in order to translate ionic compounds into ions, you have to know your elemental ions by heart. Remember that this information is present on the website. It's stuff that we did a long time ago. So if you didn't download those documents and you haven't memorized the elemental ions, you need to complete that. Secondly, you have to know your polyanions by heart, along with the charge. Otherwise, as you'll see in some of these examples, you're not going to be able to do the translation because you won't be able to find the charge on the cation. And lastly, make sure that you've memorized the polycation ammonium, because of the molecular ions, this is the only one that has a positive charge on it. So these three things right here are super important, and because we're not meeting in class every single day right now, and where you have homework, you have time to do this. All right, now let's go ahead and launch in to the translation. So here is an ionic compound, and the question is, if we're going to write a precipitation equation and we have to write a net ionic equation, for example, you have no choice. You're going to have to translate this into ions. And the question is, how do we do that? Because the chromium is a transition metal, right? And the problem with transition metals is they can have more than one kind of charge on them. All right, so how do we figure out what the charge is on this? And the way it's going to be done is by working through the polyanion. And so this is what I meant over here on the right side. You have to have these memorized. So this polyanion is carbonate, and carbonate is CO3 minus 2. The charge is minus 2. Now, you have to pay attention to the fact that there is a 3 subscript right here, which means that there are 3 carbonates inside this parentheses for a grand total of minus 6, right? And where I got that number from was the fact that there are 3 carbonates and each one is worth minus 2. So the total is minus 6. So that means over here, these 2 chromiums, right? That's what the 2 means, that there are 2 CRs here. So these 2 CRs have to be equal to a grand total of plus 6, because these 2 values have to sum to 0. So minus 6 plus 6 is equal to 0, right? So now solving for the chromium, all right, the chromium is going to equal plus 6 divided by 2, or it's going to be plus 3. So now we can write an ionization equation for this. Ionization equation. So we have Cr2, then we have the CO3, and there are 3 of these. And then when it forms its ions so that we have a balanced equation, there's going to be 2 Cr plus 3s plus 3 CO3 minus 2s. Okay, let's look at another example. I'm just going to box this so it's out of the way, all right? And the next example that we're going to look at will be sodium phosphate. And its chemical formula looks like this. Now, if you're with it, you probably recognize already that there's actually 2 ways to figure this one out. In the last example, there was only one way. We had to know the polyanion in order to sort it out. Here, you got two ways you can go with this. Number one, you should recognize that the Na is out of group 1A. All right, and all group 1A cations are +1. All right, and again, you should have that memorized from number one over here. All right, now let's just say for the sake of argument you don't. Well, you should also have the phosphate memorized because you know your polyanions, or at least I hope that you do. And the phosphate is PO4 minus 3. All right, and you can see in the formula there's only one. Right, there's only one of these units here, but there's 3 of the sodiums. All right, so we're going to have 3 Na plus, and that is equal to a grand total for the polyanion of -3. Now when we divide both sides out, you can see that the sodium is going to be +1. And I shouldn't have written this way. Should just make it a plus. Because the grand total, yeah. Sorry, I got sidelined for a minute. This is -3, and the grand total over here is +3. And when we add these together, we should be getting 0. So this is, each sodium is going to be worth +1. All right, so now when we write the ionization equation for this, the chemical equation that shows how these ions separate, it's going to be 3 Na pluses plus PO4 minus 3. That would be the correct ionization equation. So I'm going to go up here, I'm going to make sure to label this. This is ionization. It shows the formation of ions. And this is ionization, not to be confused with precipitation, which is the formation of a solid. So these are ionization equations. Well, let me just draw a line down like this. All right, now let's look at our next example. So the next example I've chosen, let's go to one that's more complex again. So this is, let's go for copper nitrate. All right, now, again, the copper here, this is a transition metal again. And we don't know the charge on transition metals because they can be more than one type. Copper, normally, the way it comes in nature, is could be Cu+1 or Cu+2. These are the common ones. All right, so again, what we're going to do is rely on the polyanion. The polyanion here is nitrate. Again, you need to have this memorized, and the charge is -1, so it's nitrate, NO3 -1. And note that there are 2 of them inside the parentheses. So that means that for the polyanion, we have a net charge of -2. And again, the overall chemical compound has to sum to 0. That means the copper has to be a grand total of +2, where the total here is 0. All right, so since there's only one copper here, right, the subscript here, even though we don't show it as a 1, so the copper is going to be Cu+2. So let's go ahead and write the ionization equation. We're going to form ions, so we rewrite the chemical compound that looks like this. We have an arrow, and then we're going to have, whoops, made a mistake. Let me just fix that really quick. Okay, so then we're going to have Cu+2, and then that's going to be added to 2 NO3 minuses, and this is ionization. Okay, now let's look at another screen, another example. So for this one, let's do iron 3 yeah, we can do that one. Iron 3 hydroxide. So again, even though I just said the name, and for those of you who are with it, you've already sorted out therefore what's going to happen here, but let's just go ahead and practice. Again, iron is a transition metal. So we don't know the charge on it, and typical forms of iron, are going to be Fe plus 2, the common ones, and Fe plus 3. These are the common forms. All right. So again, you don't know what the charge is on the cation in this case, but you can rely on the polyanion. All right. And again, you should have the polyanions memorized, and if you do, then you realize that the hydroxide here is OH minus 1. And you can see from the chemical formula that there are 3 of them in the parentheses. 3 of them. So that means the net charge of everything that's in the parentheses is going to be minus 3. And that makes the iron here plus 3 because these two values have to sum to 0. So now we can write the ionization equation. We rewrite the chemical compound. We need an arrow, and then we're going to have, and change the color again, then we're going to have Fe plus 3 plus 3 hydroxides. All right, let's look at yet another example. The next one we'll do zinc chromate. So we're going to have Zn and then chromate. Okay, picking up where I left off, the next one we're going to do is zinc chromate. Remember that zinc is also a transition metal, but it's special because this is one of the triad. All right, and it has a fixed charge on it, doesn't require a Roman numeral. So you should recognize, again, this is part of the elemental ions that you should have memorized. You should know the triads. So it's zinc plus 2. Let's say that you don't know that. Then you're going to have to rely again on the polyanion. And this particular polyanion is the polyanion chromate. All right, and it has its structure and its charge is going to be CrO4 minus 2. And you can see when you look at the formula that both the cation and the anion are present in a 1-to-1 ratio. So it's 1 zinc paired with 1 chromate, and therefore the zinc must have a charge of plus 2 on it. So again, if you didn't have the zinc memorized, along with the triad is zinc plus 2, aluminum plus 3, silver plus 1, and sometimes the teacher is going to throw in cadmium plus 2. All of those have fixed charges on them. They should be memorized right alongside with the elemental ions. All right. Now let's go ahead and look at the ionization equation. So we rewrite the compound, use an arrow. All right, and then this is going to split into Zn plus 2 plus CrO4 minus 2. All right, and then one last one that we'll do here quick. This is a compound that you've used in the laboratory off and on, especially in the fall. So we have KMNO4, potassium permanganate. Potassium permanganate. All right. So you got a couple avenues to go forward here because potassium is out of group 1A. I'm just going to abbreviate this, and you should have those memorized. So it should be immediately apparent that this is K plus 1. And then we also have the permanganate ion, and that's one of your polyanions. You should realize that it's MnO4 minus. So the charges on both of these are the same. Again, if you don't have the elemental ions Memorize, then you had to completely rely on your knowledge of the polyanion in order to do this. So let's quickly write the ionization equation. So it'll be K plus MnO4 minus. All right, this concludes lesson 1 on types of reactions, and the main goal here was to review how to take ionic compounds and split them into ions, which you're gonna have to be able to do that in order to write ionization equations.